Hello friends, welcome to the world of discrete mathematics with me Kunal Airi on my YouTube channel. Here we are going to learn about the concepts of discrete mathematics. Let's start with the new topic of discrete mathematics is cardinality of finite sets. In the analysis of computer algorithm, we always require to count the number of operations executed by the various algorithms. So this is necessary to estimate the cost effectiveness of a particular algorithm. Hence, we require to study the cardinality of finite sets and understand the properties related with the cardinality of finite sets. Let's start with the definition of cardinality of a set. Let A be a finite set. A be a finite set. Then the cardinality of A is denoted by this symbol, or we can write n of A as the number of elements in the set. If A is equal to empty set, means we get cardinality of A is equal to 0. Now let's consider another example. A is equal to A, E, I, O, U, collection of vowels. So we get cardinality of A is equal to 5. So what is the cardinality of A? Let A be a finite set, then the cardinality of A is denoted by this symbol, or n of A is the number of elements in the set. Now the second point is theorem number 1, that is the addition principle. Again, let's consider A and B be the two finite sets which are disjoints. Disjoint means what? They don't have common elements, right? That is, cardinality of A intersection B is equal to 0. So therefore number of A union B is equal to number of A plus number of B. This principle is considered as the addition principle. Now एडिशन प्रिंसिपल कब अप्लाई होने वाला है आप लोगों का? जब इंटरसेक्शन यहाँ पे एम्प्टी रहेगा, मीन्स नंबर ऑफ ए इंटरसेक्शन बी इज इक्वल टू 0. So this is the theorem number 1, the addition principle. Number of A union B is equal to number of A plus number of B. Now let if A1 A2 dot 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 AN be a finite collection of mutually disjoint sets, then we can write A1 union A2 union dot 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 AN cardinality complete is equal to number of A1 plus number of A2 plus dot 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 plus number of A. So this is the corollary for the addition principle. Next point is theorem number 2, difference between the sets. This theorem is related with the difference between the sets. Let A be any finite set and capital B be any set. Then the cardinality of A minus B is equal to cardinality of A minus cardinality of A intersection B. Cardinality means what? Number of elements present in that set. So number of A minus B is equal to number of A minus number of A intersection B. Otherwise, if we have to find out B minus A, that time we get number of B minus A intersection B. That is the number of A intersection B. So these are the 2 points related with the difference between the 2 sets. Next theorem, that is the most important theorem, principle of inclusion exclusion. It is related with the 2 sets. let A and B be finite sets, then number of A union B is equal to number of A plus number of B minus number of A intersection B. Now look, addition principle और प्रिंसिपल ऑफ इंक्लूजन एक्सक्लूजन अगर हम लोग कंपेयर करें तो यहाँ पे आपका इंटरसेक्शन अवेलेबल है, राइट. फॉर द एडिशन प्रिंसिपल इंटरसेक्शन क्या रहेगा, वहां पे एम्प्टी सेट रहेगा, मींस नंबर ऑफ ए इंटरसेक्शन बी वहां पे क्या रहेगा, 0 रहेगा. सो दिस इज द बेसिक डिफरेंस बिटवीन द एडिशन प्रिंसिपल एंड प्रिंसिपल ऑफ इंक्लूजन एंड exclusion. So number of A union B is equal to what? Number of A plus number of B minus number of A intersection B. Now next theorem, number 5, that is mutual inclusion principle for 3 sets. Now this theorem is related with the 3 sets. Let A, B, C, these are the 3 finite sets. Then number of A union B union C is equal to number of A plus number of B plus number of C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So this is mutual inclusion exclusion principle for 3 sets. Number of A union B union C is equal to number of A plus number of B plus number of C minus A intersection B minus A intersection C minus B intersection C plus number of A intersection B intersection C. Let's consider the next theorem, that is mutual inclusion exclusion principle for the 4 sets. Let's consider the 4 sets A, B, C and D. Again these 4 sets are a finite sets. Then number of A union B union C union D is equal to number of A plus number of B plus number of C plus number of D minus A intersection B minus A intersection C minus number of A intersection D minus number of B intersection C minus number of B intersection D minus number of C intersection D, then plus A intersection B intersection C plus A intersection B intersection D plus number of A intersection C intersection D plus B intersection C intersection D, and the last term is minus A intersection B intersection C intersection D. So this is mutual inclusion exclusion principle for 4 sets. Number of A union B union C union D is equal to number of A plus number of B plus number of C plus number of D minus number of A intersection B minus A intersection C minus number of A intersection D minus number of B intersection C minus number of B intersection D minus number of C intersection D plus A intersection B intersection C plus number of A intersection B intersection D plus number of A intersection C intersection D plus number of B intersection C intersection D, and the last term is minus number of A intersection B intersection C intersection D. So these are the 5 main points related with the cardinality of finite set. The first one is addition principle. एडिशन प्रिंसिपल जब यूज होगा दैट टाइम ऑलवेज रिमेंबर ए इंटरसेक्शन बी वहां पे आपका एम्प्टी सेट रहेगा, मींस नंबर ऑफ ए इंटरसेक्शन बी इज इक्वल टू 0. सेकंड वन डिफरेंस बिटवीन द सेट. थर्ड वन इज प्रिंसिपल ऑफ इंक्लूजन एक्सक्लूजन. फोर्थ वन इज म्यूचुअल इंक्लूजन एक्सक्लूजन प्रिंसिपल फॉर 3 sets, and the fifth one is mutual inclusion exclusion principle for the 4 sets. Now let's solve the example related with the cardinality of finite sets. First example. In a survey, 2000 people were asked whether they read India Today or Business Times. It was found that 1200 read India Today, 900 read Business Times, and 400 read both. find how many read at least one magazine and how many read none. So how many sets are there? तो यहाँ पे अगर sets find out करना है तो initially we get the first set, that is the universal set, 2000 people. Okay, now the next one is 1200 read India Today. Then after that 900 read Business Times. Okay, so how many sets are there? 3 sets. Let consider A be the set of people who read India Today and B be the set of people who read Business Times. Now number of U is equal to what? 2000. Number of A is equal to 1200. Number of B is equal to 900. Now यहाँ पे statement check कीजिए, 400 read both. Read both means here A intersection B is equal to 400. So this is the given data. Now what we have to find? How many read at least one magazine? How many read at least one magazine means we have to find the union between A and B. Okay, so first one, what we have to find? Number of A union B. So by using mutual inclusion principle, number of A union B is equal to what? Number of A plus number of B minus A intersection B. Now put the values. What is number of A? 1200. Then number of B 900 and the common element, that is a 400. So is equal to 1200 plus 900 minus 400, we get 1700. So 1700 read at least one magazine. So this is the first answer. Now what is the second condition? Second condition is how many read none. यहाँ पे आप लोगों को क्या find out करना है कि कितने लोग magazine read नहीं कर रहे हैं. So what we have to find? Simple. Universal set is equal to what? 2000 और number of people read at least one magazine कितना मिल रहा है हम लोगों को? 1700. So simple. So we have to find out U minus A union B. So what is U? That is a 2000 minus 1700. We get 300. So 300 people. Now 300 people read none magazines. So this is the second answer. Now let's see example number 2. Among the integers 1 to 300, find how many are not divisible by 3 nor by 5. Find also how many are divisible by 3 but not 7. So again यहाँ पे number of sets सबसे पहले हम लोगों को find out करना है. So how many sets are there? 3 sets. The set number 1 is a divisible by 3. Divisible by what? 3. Now the second set is divisible by 5 and the third set is divisible by 7. For the 3, consider A be the set, second one is a B and the third one is a C. So A be the set of integers which is divided by what? 3. Second one divided by 5 and the third one is divided by 7. Now यहाँ पे क्या find out करना है? How many are not divisible by 3 nor by 5? Right? That is a complement. Because we consider that A be the set of what? A be the set of numbers which is divisible by 3. Means A complement be the set of numbers which is not divisible by 3. Same for the 5, right? That is the set B. Means not divisible by 5 means we get a B complement. And not divisible by 7 means we get a C complement. So first one, what do you have to find? The numbers which are not divisible by 3 not by 5. So not divisible by 3 means we get A complement and not by 5 means we have to find out intersection between not divisible by 3 nor by 5. Now by using De Morgan's law, now what is the De Morgan's law? That is A complement intersection B complement is equal to A union B complement. ये प्रॉपर्टी आपका यहाँ पे यूज होने वाला है, right? This is equation number 1. Now by using the property of difference and related property of difference and complement, that is a complement is equal to u minus a. A complement is equal to what? U minus a. Therefore a union b complement is equal to what? Number of u minus a union b. This is equation number second. So here first we have to find out a union b. So a union b is equal to what? Number of a plus number of b minus number of a intersection b by using mutual inclusion principle, right? So this is the inclusion exclusion principle. Now here we have to find out number of a, then number of b, and then number of a intersection b. Now number of a is equal to, अगर एग्जाम्पल्स अमंग द इंटीजर्स 1 to 300 है, सो ऑलवेज रिमेंबर अगर यहाँ पे नंबर ऑफ ए फाइंड आउट करना है तो 300 डिवाइड बाय 3 करना है यहाँ पे, राइट? सो 300 डिवाइड बाय 3 इज इक्वल टू व्हाट? 100. ओके, अगेन यहाँ पे अगर कोई पॉइंट वैल्यूज मिल रहा है तो वी हैव टू कंसीडर ओनली नंबर्स. फ्रैक्शनल पार्ट आप लोगों को कंसीडर नहीं करना है. नाउ नंबर ऑफ बी which is divisible by what? B is divisible by 5, so we get 60. Then we have to find out A intersection B. अगर इंटरसेक्शन फाइंड आउट करना है तो A सेट क्या है आप लोगों का? डिविजिबल बाय 3 और B क्या है? डिविजिबल बाय 5. So 3 5s are 15. So 300 divided by 15 we get a 20. Okay, so put this value in equation. Which equation? That is number of A union B is equal to number of A plus number of B minus A intersection B. So we get number of A is equal to 100 plus 60 minus 20. So we get 140. So this is next equation. Okay. Now put this value in this equation. A union B complement is equal to number of u minus A union B. So we get 300 minus 140 is equal to 160. So hence 160 integers between 1 to 300 are not divisible by 3 nor by 5. So this is the first answer. How many are not divisible by 3 nor by 5? So कितना आंसर मिल रहा है हम लोगों को? 160. So 160 integers between 1 to 300 are not divisible by 3 nor by 5. Now second condition. What is the second condition? How many are divisible by 3 but not by 7? Right? So यहाँ पे find out क्या करना है कि divisible by 3 but not by 7. Let's consider these are the two diagrams. One is for, this is for set 3 and this is for set 7. Means this is set A and this one is set C. Now what do you find? The numbers which are only divisible by 3 means we have to find this shaded portion. ये portion हम लोगों को find out करना है, right? अगर ऑलरेडी हम लोग वेन डायग्राम चेक कर चुके, ये पोर्शन आपका कहाँ पे मिलता है? डिफरेंस बिटवीन द टू सेट, दैट इज a माइनस बी. सो a माइनस बी अगर हम लोग फाइंड आउट करते तो फॉर्मूला क्या रहता है? नंबर ऑफ a नॉट अ प्लस, नंबर ऑफ a माइनस a इंटरसेक्शन b, राइट? सो दिस इज द फॉर्मूला, नंबर ऑफ a माइनस नंबर ऑफ a इंटरसेक्शन b. सो यहाँ पे आपको क्या फाइंड आउट करना है? डिविजिबल बाय 3 नॉट बाय 7. 7 मीन्स क्या, कौन सा सेट है हम लोगों का? C. 3 कौन सा सेट है हम लोगों का? A. मीन्स वी हैव टू फाइंड द सेकंड कंडीशन, दैट इज नंबर ऑफ A माइनस C. सो क्या फॉर्मूला क्रिएट होगा? नंबर ऑफ A माइनस नंबर ऑफ A इंटरसेक्शन C. सो वी हैव नंबर ऑफ A का वैल्यू हमारे पास है, राइट? कौन सा नंबर आया था हम लोगों का? दैट इज 100. नंबर ऑफ A इज इक्वल टू 100. व्हाट वी हैव टू फाइंड? नंबर ऑफ A इंटरसेक्शन C. A सेट 3 के लिए है और ये सेट आपका 7 के लिए. सो 3 7 3s are 21. So 300 divided by 21 we get 14. So put this value, यहाँ पे वैल्यू पुट कर सकते हैं अभी. So first one, A, number of A 100 minus 40. So we get 86. So hence 86 integer between 1 to 300 divisible by 3 but not by 7. जहाँ पे divisible by 3 आ रहा है but not by 7. So remember यहाँ पे हम लोगों को number of a minus number of c find out करना है. In next lecture we'll see the examples related with the same concept, that is principle of inclusion exclusion, mutual inclusion exclusion principle for the 3 set as well as for the 4 sets. If you like my video, then like it, share it and subscribe to my YouTube channel. For the more videos related with the discrete mathematics, don't forget to click on the bell icon button.